Hello everyone, in this video we're going to explore topic 9.3 arc length of curves parametric equations. Alright, so previously we know that arc length formulas for a curve defined by y of s on the interval s0, s1 is given by the formula the integral from s0 to s1 square root of 1 plus dy over ds squared ds, right? Now, if our curve is represented by parametric equation s equals f of t, which means the function s with respect to t, y equals g of t for t from a to b inclusive, and ds over dt is the first derivative of the function s with respect to t greater than 0. We can rewrite this one as the integral from s0 to s1, the square root of, rewrite 1 right here. Now, I'm going to divide the top bottom by dt squared, right? So I get this one right here, right? Now, 1 right here can be written as ds over dt squared. That's why we're going to write this one in the same denominator, ds over dt squared, right? Now, for ds right here, I just multiply the top and bottom by dt, right? So I get this one right here, right? Now, I'm going to print this one outside the square root sign. So does that mean I have the integral from s0 to s1 square root of over ds over dt, right? Multiply by ds over dt, right? Multiply by dt. This guy right here and this guy right here cancel out, right? That's why you get this one right here, right? Now, ds over dt actually derivative of the function s with respect to t. You got this one. And dy over dt is the derivative of the function y with respect to t. That's why you have the formula right here, right? Now, the arc length in parametric form is going to be given by this formula, right? Note that when applying the arc length formula to a curve, be sure the curve is traced out only once on the interval of the iteration. For instance, s equals cosine t and y equals sine t is traced out once on the interval 0 to 2 pi, but is traced out twice on the interval 0 to 4 pi, right? Now, arc length and distance traveled, we're going to use the same formula, right? Now, let's take a look at the first example. Find the arc length for a parametrically defined curve. Find the arc length of a curve defined by st equals tq plus 2 and y of t equals 2 times t power of 9 over 2 on the interval 1 to 3, right? So, you're going to take the first derivative of the function s of t, right? So it turns out to be 3t squared, right? Y prime of t equals 9t power of 7 over 2, right? Then by the formula we got right here, right? So the arc length equals integral from 1 to 3, right? Of square root of s prime of t squared, which is 3t squared altogether squared, plus y prime of t squared, which is 9t power of 7 over 2 square dt, right? So this guy turns out to be the integral from 1 to 3 square root of 9t power of 4 plus 81 t power of 7, right? dt, right? Now I'm going to factor 9t power of 4 out. So it's going to be integral from 1 to 3, 9t power of 4 times 1 plus 9t cubed, right? Alright, so I can print 9t power of 4 out. So it's going to be integral from 1 to 3, 3t squared times square root of 1 plus 9t cubed dt, right? Now I'm going to use u substitution to solve this one, right? So I'm going to let u be square root of 1 plus 9t cubed, right? So I have u square equals 1 plus 9t cubed, right? Take the derivative both sides, so I have 2u du equals 27t squared, right? Now, outside of the square root side, you only see 3t squared dt, right? Then I'm going to divide both sides by 9. So it's going to be 2 over 9 u du, right? Equals 3t squared dt, right? Then I'm going to change the lower bound and upper bound. The lower bound is t equals 1, upper bound t equals 3. We have the new lower bound and upper bound, right? U equals, substitute 1 for t into this guy right here, right? So u equals square root of 10. Now substitute 3, this going to be 27, right? 27 times 9. It's going to be 243 plus 1 is going to be 244, right? So it's going to be u equals square root of 244, right? Now, L becomes the integral from square root of 10 to square root of 244 of this guy right here, actually u, right? And this guy right here turns out to be 2 over 9 u du, right? 2 over 9 u du. So this guy turns out to be 2 over 9 u cubed over 3 evaluated from square root of 10 to square root of 244, right? So it's going to be 2 over 27 times square root of 244 cubed minus square root of 10 cubed, right? And this one is the final answer. Now let's move on to the example number 2. Find the distance traveled. A particle moving along a curve in the xy plane is at position s of t, y of t at time t for t greater than or equal to 0, where this s over dt equals inverse tangent of e to the negative t, and the y over dt equals 3t over 1 plus 4t cubed. Find the distance traveled by the particle on the time interval t from 1 to 2 inclusive, right? So you have arc length equals the interval from 1 to 2, right? It's going to be right here, right? Square root of s prime of t actually is going to be right here, square, right? So it could be inverse tangent of e to the negative t square plus y prime of t square, which is this guy right here, right? 3t over 1 plus 4t cubed square dt, right? Now, of course, you're going to use the calculator to calculate this one, right? So you're going to press menu, calculus, integral from 1 to 2. After you input the expression right here, you just hit enter. The answer is 0.406, right? Now let's move on to the theorem 9.3b. Error of the surface of revolution. Alright, if a smooth curve C is given by the equation s equals f of t and y equals g of t, such that C does not intersect itself on the interval a to b, then the error s of the surface of revolution formed by revolving C about the coordinate axis is given by the formula s equals 2 pi integral from a to b y of t. This one actually the radius s prime of t squared plus y prime of t squared, right? Now when you revolve the curve about the x-axis, then you have the radius, which is y of t should be perpendicular to the x-axis. Alright. Similarly, if you revolve the curve about the y-axis, so you have the radius s of t is perpendicular to the y-axis, right? Keep in mind the radius must be greater than or equal to 0, right? Okay, let's take a look at example number 3. Find the area of surface of revolution. Let's see period of the circle x squared plus y squared equals 9. From 302, 3.5, 3 root 3 over 2 as shown in the figure at right. Find the area of the surface from by revolving the curve C about the x-axis, right? So the radius should be this guy, right? And this guy actually y of t, right? Observe that this one is the rectangular form. Now you learn from AP pre-calculus. You need to convert this one to polar form, right? So you know that S of t equals r cosine t, right? The radius right here is square root of 9, which is 3, right? So it's going to be 3 cosine t, right? Now y of t equals r sine t. So it's going to be 3 sine t, right? Now you need to take the derivative of this one with respect to t. So I have s prime of t is negative 3 sine t, right? And this one s prime of t equals 3 cosine t, right? Now you need to square this one, so this guy turns out to be s prime of t square equals 9 sine square of t, right? And y prime of t square is going to be 9 cosine square of t, right? Now you need to find the boundaries of intersection, right? So this one right here is the x-coordinate, right? Since the arc length right here revolving about the x-axis, you need to use x-coordinate, right? So you have 3 cosine of t equals 3. You need to solve for t, right? So cosine of t equals 1, right? So then t equals 0. Now second one, 3 cosine of t equals 3.5, right? Then cosine of t equals 1/2, right? Then t equals pi over 3, right? So the area of the surface is given by the formula s equals 2 pi, the integral from 0 to pi over 3, right? Times the radius. The radius in this situation is y of t. Y of t is right here, right? Times square root of s prime t square plus y prime t square, which is right here, right? So you have 9 sine square of t plus 9 cosine square of t. And then don't forget dt, right? So I'm going to simplify this one. It's going to be 2 pi times the integral from 0 to pi over 3, 3 sine t. Now if I factor 9 out, does that mean I have sine square t plus cosine square of t, right? But sine square t plus cosine square t equals 1. So this guy is equals 9, right? And take square root both sides. So the answer is 3, right? So this guy turns out to be 3 times 3 equals 9, right? dt. So it's going to be 18 pi. Now anti-derivative of sine is going to be negative cosine, right? So you have negative side right here. Cosine of t evaluated from 0 to pi over 3, right? And then it's going to be negative 18 pi times, substitute pi over 3 for t, right? This is going to be cosine of pi over 3. Substitute 0 for t is going to be negative cosine of 0, right? So it's going to be negative 18 pi times cosine of pi over 3 equals 1 half, right? Cosine of 0 equals 1, right? Subtract 1. So it's going to be negative 18 pi times negative 1 half, right? So it could be 9 pi, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.